In today's session, let we learn about another combinational circuit, which is a decoder circuit. And these decoder circuits are used in data transmission for decoding your inputs from binary to the other number system. Now, let me move to the least order decoder, which is a 2 by 4 decoder. Thereafter, we'll move to your 3 to 8 decoder. Now, generally, the block diagram of your decoder, which consists n number of inputs with 2 power n number of outputs. So a combination circuit which can change the binary information, n bits of binary information into 2 power n number of output lines is known as a decoder circuit. Now it would take n number of input lines and gives you the outputs, which is 2 power n number of a bit code, which is in the form of binary. It produces 2 power n number of output codes which are equivalent to that of your given binary information. Now 2 to 4 line decoder. So here the first number will define the number of inputs and the second number will define the number of outputs. Now here, as it is 2 to 4 line decoder, it will have 2 number of inputs. If it is having 2 number of inputs, the number of output available in this decoder is 2 power 2, which is equal to 4. So now let me symbolize your inputs with A0, A1. In addition with these two inputs, you are also using a enable input in order to control the operation of your 2 to 4 decoder. We are introducing a enable input, simply acting like a control signal for operating your decoder circuit. Now, as we have here 4 number of outputs which are labeled as Y0, Y1, Y2 and Y3. So based on your input combination, only one of the output is transferred with the logic 1, and that depends on your what you apply on your inputs of your A0 and A1. So based on the inputs applied logical levels on your A0 and A1, so one of the output will be transferred with logic 1. The remaining all the outputs will give you the logical 0. Now coming to this is your block diagram of your 2:4 decoder, where it consists 2 inputs along with a control signal enable input. Next, it will have your 4 number of outputs which are labeled as Y0, Y1, Y2 and Y3. Now, so until unless your enable input is 0, so it doesn't see that which input combination you applied on your inputs of your 2 to 4 decoder. Hence, all the outputs will give you the 0 outputs. If enable input is 1 and your inputs are A1, A0 are 0, 0, the first output, the logical one, is transferred to the first output, which is Y0. The remaining outputs will give you 0 outputs. Next, if enable input is 1 and input combination on your A1, A0 is 0, 1, so Y1 is transferred with logical 1, output Y1 is transferred with logical 1. Remaining outputs would give you the output 0. So if enable input is 1 and inputs applied on your A1, A0 is 1, 0, then Y2 output is transferred with logical 1. The remaining outputs Y0, Y1, Y3 become 0. So if it is 1, 1, so on your inputs, so your output of Y3 is transferred with the logical 1. The remaining outputs will give you the logical 0. So now as if we write the Boolean expressions of your each output, Y0 resembles here. So in terms of E and A1, A0 as a product term, so Y0 is equal to E into A1 bar into A0 bar. Since the logical functional value of this output function is 1, for a combination of A1, A0 is 0, 0 with an enable input 1. So now we are doing the AND operation between these three variables, then we obtain your output y0 is equal to 1. So y0 is equal to E into A1 bar into A0 bar. As here we substituted 0 on your A1 and A0. So these variables in the product term is represented with complement. So hence y0 is equal to, it's a product term of in between that E input, which is enable input, and their inputs of your decoder A1 bar into A0 bar. Y1 is equal to E into A1 bar into A0. Y2 is equal to E into A1 into A0 bar. Y3 is equal to E into A1 into A0. So as here I mentioned that output expressions where Y3 become logic 1 if A1 and A0 are logical ones. Y2 is 1 if A1 is 1 and A0 is 0 along with enable input is 1. Y1 become logical 1 if E equal to 1, A1 becomes 0, A0 is 1. So y0 is 1, logical 1 if and only if enable input is 1, both A1 and A0 become 0. So these are the output Boolean expressions of your 2 to 4 line decoder of 4 outputs. Let me draw the logical diagram of these 4 outputs. Now these 4 outputs are resembles your AND terms, and hence we were taken of 4 sets of AND gates in this logical diagram. Now each output of AND gate will give you one of its outputs started with y0, y1, y2, y3 as enable input. If it is 0, now we've discussed in the truth table that until unless your enable input is equal to 0, so if it is 0, your outputs of your every output of your decoder become 0. So if enable input is 0, if enable input is, it is acting like a control signal. Hence, so since we are connected your enable input as one of the input of your decoder. So now if any input is 0 and logic is, if any input is 0, output of your and become logical 0. So if enable input is 0, outputs of your all these 4 number of and gates outputs become logical 0. So hence, so no input will be decoded at the output. So if enable become 0. Next, in order to decode your inputs at the output, so we make sure to have your enable input is 1. Now when enable input is 1, outputs of each AND gate depends on depend depends on your applied inputs of A1 and A0. So now here Y0 is logic 1. So whenever you apply your A1 bar and A0 bar, as here we connected, so that with this line, so to A1 bar and A0 bar. So this line belongs to the A0 bar and this line belongs to the A1 bar. So if enable input is 1 and if you apply your logical levels on your A1 and A0 is 0 0. So if it is 1, so then zeros are transferred through this NOT gate which will give you the logical 1. So hence output Y0 become logic 1 and the remaining outputs all will give you the, for that combination of A1 A0 0, so it will give you zeros. Next, if it is 0 1, so then output and with an enable input 1, so then here we connected the second AND gate inputs from A1 bar and A0. So as it is A1 bar and A0, so A1 is 0, so 0 because 0 complement is 1, and then A0 is for a combination of 0 1, it will be 1. So hence output for such combination of your applied input 0 1 on your inputs of decoder, it will give you the logic 1. The remaining output so of your AND gates will give you the logical 0 outputs. Next, for a combination of 1 0 on your A1 A0, the third AND gate output become logic 1. The remaining gates will give you the logical 0 output. So as it is connected, the third gate input is connected with A0 bar and A1. So now A1, since A1 is 1, 1 is transferred, and A0 is 0, 0 is complemented with this NOT gate. So then here we will obtain 1. As E is 1, only for this third AND gate all three inputs are logic 1. Hence you obtain your Y2 is equal to 1. The remaining will give you the outputs as zeros. Next, for a combination of your input, which is 1 1, along with enable input is 1. So your fourth AND gate will give you the output is 1, and the remaining gates will give you the logical 0 output. So like this, so your 2 to 4 decoder will be operated based on your enable input as well as on your input combination, which is applied on your inputs of the decoder circuit. So each output of your AND gate would generate one of the minterm. So this fourth AND gate will generate the minterm M3. This third AND gate will generate the minterm M2, and this AND gate 2 is generating your minterm M1. The first AND gate will generate your minterm M0. So here these decoders are also used to implement your Boolean functions. Next, let me move to your the designing of 3 to 8 line decoder. As in this, so it is having 3 number of inputs and 8 number of outputs. We label that inputs along with the enable input is A0 to A2. A0, A1, A2 are the inputs of your 3 to 8 decoder, and number of outputs available for this decoder is Y0 to Y7, which are labeled as Y0, Y1, Y2, Y3, Y4, Y5, Y6, Y7. Until unless your E input, enable input is 0 or control signal is 1, no input signals are decoded at the output. So no output will give you the result of logic 1. So if enable input is 1, based on your input combination which you applied on your inputs of 3 to 8 decoder, one of the output will generate your logical 1, the remaining will generate your logical 0. Now this is your logical diagram of your 3 to 8 line decoder along with your truth table of your 3 to 8 line decoder. If enable input is 0, all outputs are zeros, and this might be zeros or ones. So we have just mentioned with the don't care combination. So might they are 0 or 1. Since enable input 0, all the outputs will give you 0. So your circuit will not respond until unless the enable input is logic 1. So now enable input is connected to the all the inputs of your it is acting like one of the input of your AND gates, all 8 AND gates. Next, based on your output expressions of Y0. So here I have not mentioned your enable input, so you can also include it. So now Y0 is equal to A2 bar into A1 bar into A0 bar. Y1 is equal to A2 bar into A1 bar into A0, 0 0 1. So Y2 is equal to A2 bar into A1 into A0 bar. So next Y3 is equal to logic 1 whenever you apply a input combination on your A1, A0 to A3 is 0 1 1. So Y4 is, so A2 become logic 1, A1 is 0, A0 is 0. Hence we are represented that logical Boolean expression as A2 into A1 bar into A0 bar. Y5 is equal to A2 into A1 bar into A0, Y6 is equal to A2 into A1 into A0 bar. Y7 is all logical levels which is substituted on inputs are logic 1, hence all the variables are represented without complement as a product term. So since you have 8 number of AND gates which each generates your one of the output. So based on your enable signal, so it will, your inputs are decoded at the output. Only one output is transferred with logic 1 for a certain combination of your input. So which output is enabled, that depends on your applied input combination on your decoder inputs. Thank you, Ma. So this is our session. In the next class, we're going to learn about your encoder circuit.